Hello! So, you have your next exam coming up this coming Thursday. I hope you are well aware of that, and I want you each to be able to dominate this next exam. Let's go over a few topics that you are almost for sure going to see on this exam, starting with, function transformations. So, the question here off of our exam review says, given the following function, g of x, you want to list the transformations that transform f to g. So we're starting with some arbitrary function f of x, right? We're starting with f of x. We don't know what the function f of x even is, but we then do some transformations to f of x, and we end up with g of x, which is going to be equal to -3 times f of x plus 5 minus 8. Now, remember that anything inside of the function is going to affect the x's or the domain, and anything outside of the function is going to affect the y's or the range. So what do I mean by inside and outside? Well, look at this function here. We start with f of x. See how this x plus 5 is like inside of the function, and then everything else, the -3 and the -8, is outside of the function. So anything inside is going to affect the domain or the range. So if you have like a plus or minus inside of the function, that's going to be a horizontal shift, either going to the left or to the right. Now, in a sense, it really is the opposite direction. So an x plus 5 inside the function, that's going to shift you 5 units, but 5 units to the left. So we have a shift here, left by 5. So we do a horizontal shift. And that's going to be to the left. So we're going horizontal shift, which is going to be going left by 5 units. And then what else is happening? While we have outside, we're multiplying by a 3, and then a negative is going to be a reflection, but the 3 outside is basically going to be a stretch. So that's going to be a vertical stretch by a factor of 3. So by a factor of 3, and then we have a negative. That's going to be a reflection. It's either going to be a reflection over the x or over the y. But remember, anything outside affects the y's. But think of if we reflect over the x-axis, then every point basically gets reflected, and then if it's over the x-axis, well, the x value of that point stays the same, but all the y's get reflected to the negative of whatever the y value was. So therefore, it's going to be, since it's outside, it affects the y's, that's going to be a reflection over the x. You want to right here go ROX. That means a reflection over the x, and then we have a -8 outside. That's going to be a vertical shift up or down, and if it's a vertical shift, it's the same direction. So if it's plus something, we go up by that amount. If it's minus, we go down by that amount. So a -8 outside is going to be a vertical shift down by 8 units. So that's it, basically. We start with whatever f of x was, and we do the shift left by 5, the vertical stretch by 3, the reflection, which is the negative outside over the x-axis, and then down by 8 units. All right, let's look at another one. Let's say we start with an actual function, which is, let's say, the square root of x. So let's say we start with f of x to be equal to the square root of x, and then we have some transformation done to f of x, and we end up with g of x. So g of x, which is now going to be equal to negative the square root of x plus 6 minus 3. So this first one, right, was just in terms of some arbitrary function f of x. This one, we actually know the function f, which is the square root of x, and we're doing transformations to end up with g of x. Well, look at the plus 6 is under the square root. So that's like inside of the function, and then the negative is outside, and the -3 is outside. So what transformations happen here? Well, since that plus 6 is inside the square root, it's going to be, again, a left or right shift opposite direction. So that's going to shift us to the left by 6 units, And then we have the negative, again, outside of the function. That's, again, going to be a reflection over the x-axis. And the -3 outside is going to be going down by 3. And then we're asked to make a quick sketch of g of x. Well, if we make a quick sketch of f of x, the square root function, you should kind of know what that looks like. The square root function looks something like so. It's only defined for positive x values, right? You put in a negative value. This is the square root. This is f of x equals the square root of x, and this is the graph of it. Because the square root of a negative value is undefined, right? That's not a real number. The square root of, let's say, -1, right, doesn't make much sense. It's an imaginary number, but in this class, it is not a real number, so that's undefined. You can see you put in a value, a negative value for x, you're not going to hit the graph anywhere. If you put in, let's say 4, maybe 4, which is here, well, the square root of 4 is 2, so you come up and you're going to hit, and this is not quite the scale, but this would be 2 on the y-axis. Now, what happens after the transformation? This is f of x. We want a sketch of g of x, which is negative the square root of x plus 6 minus 3. Well, we just shift. We go left by 6. We take this graph. We go left by 6. So this is right now the every point gets shifted. But if you look at where this point right here at the origin is going, if it goes left by 6, that would be over to -6. And then what else is happening? It's going, well, we have the reflection over the x-axis. So this would just be shifting to the left by 6. And then if we reflect it, it flips it upside down. And then if we go down by 3, the whole thing goes down by 3. And we end up with something like so. So therefore, the graph of g of x would look like, we go, again, left by 6, and then reflect over the x-axis and down by 3, and we end up with a graph that's going to look something like so. All right, so there's a quick sketch of the graph of g of x. Something else you're going to see for sure is if you have, let's say, a point on the graph. Let's say you're given some point AB. So given that AB is on the graph of f of x. So AB is a point and is on the graph of y is equal to f of x. And you want to know where that is going to go on the graph of g of x, where g of x is going to be a transformation on f of x. Again, this is some random function, f of x. I don't know what f of x is, but we're told that g of x is going to be equal to what? What's going to be equal to -5 times f of x plus 6 plus 7. And we're only told to here to say, where does AB go on the graph of g of x? Well, remember, anything inside of the function is going to affect the x values, right? And anything outside affects the y's. So AB is like an xy point. So the x plus 6 is going to the left by 6 units. So where does A go? Well, if it goes to the left, that means that whatever A was, it's going to the left. It's going to be A minus 6, right? So therefore, the new point here, A is going to go to A minus 6, because only the 6 inside of that function is going to affect the x value, which in this case is A. And then where does y go? Well, y is B, right? Well, y is B. So everything outside affects the y value. So we're going to be basically multiplying by 5, stretching it, but then reflecting it. So it goes to the negative value and then plus 7. So basically, you're just going to take -5 times B and then add 7. So therefore, B is going to go to -5B plus 7. So therefore, regardless of whatever the point AB was, after we do this transformation to get g of x, the point AB is going to go to the point A minus 6, comma, -5B plus 7. And that is our new XY point after the transformation. All right, so there I think is a few questions you're definitely going to see on this coming exam. I'll probably make another video to go over some other topics you're going to see. That's probably good, though, for one video. So I will calculate later. Take care.